Thank you. It's been an incredible privilege to be here today to learn about progress in what I personally think is the most exciting and momentous scientific challenge in perhaps the entirety of human history: understanding and working to create true intelligence. In parallel, I think one of the real challenges of our age is working to make sure that artificial intelligence is beneficial, that we can use it to help us with the biggest challenges that humanity faces in the near and the longer term, and also make sure that these benefits are distributed across our societies and across the world. So, one of the things I'd like to do with this talk is look at some of the issues that people are thinking about with the current systems we're developing, and as well some of the concerns that are being raised about future systems, in particular the idea of general artificial intelligence. Right now it feels a little bit like these communities who are looking at these issues are in some ways separate and sometimes dismissive of the work that the others are doing. And well, I have a concern that maybe this is a mistake. I think that there are more links between these areas and more opportunities and synergies than we realize. And so what I'd like to do is tease out some of these links and raise a few questions that I think might be worth thinking about. Artificial intelligence is starting to affect every aspect of life, every industry, and every country on Earth. Progress in capabilities is improving rapidly, and alongside that we're seeing this fantastic growth of a community working on impacts. It includes the scientific research leadership in academia and in industry. It includes academics across disciplines working on economic, legal, sociological, philosophical impacts. It includes policymakers and governance specialists and NGOs and nonprofits. Loosely, it can be divided into people who are thinking about near-term issues, whether it's self-driving cars on our roads or how AI is going to be used in warfare, and longer-term issues like progress towards general artificial intelligence. In the near term, well, I mean, this growth is huge. We've heard a number of wonderful talks from members of the AI Roadmap Institute, SingularityNet, Unicre, the AI Initiative, working on both near and long term. But I mean, the number of organizations is just growing massively. This is just what I could fit on a slide, but it's a small drop in the ocean in terms of the organizations getting involved. Even the Partnership on AI alone is now more than 70 organizations. And this can be bewildering, but it's also exactly what we need, bringing in to play deep expertise, not just in the technology, but in issues like human rights, labor markets, inequality, cultural differences, everything we really need in order to understand these issues at a deep level. Some of the examples of issues that people are working on in the near term include algorithmic bias, how we can make sure that AI systems don't pick up on and perhaps amplify biases, historical biases in data that they're trained on, whether it's sexism or racism or inequalities of other sorts. Explainability, how can we make sure that the AI systems we're developing are explainable, both to the research scientists who are developing them and the users who are going to be using them in a wide range of real-world settings? And how can we know when they're going to go wrong and who should be accountable when an AI system makes a mistake? Employment, labor markets, jobs. What areas of employment are likely to get automated in the near term, and how do we look after the people who might end up losing their jobs because of AI? Data privacy. AI in safety-critical settings like medicine and healthcare, also self-driving cars, transport, electricity grids, infrastructure of all sorts. Diversity and inclusion. How do we make sure that everyone who's going to be affected by AI, and increasingly that's everyone, how do we make sure that their voices are represented in the process of how we develop AI and how we deploy it, both in creating it and figuring out how it should be applied in various contexts? And then a huge number of other domain-specific issues, like how we apply AI responsibly in justice, in data management of all sorts, in commerce, in politics. The list goes on. And I'd highlight in particular great work being done by centres like the AI Now Institute, Kate Crawford and Meredith Whittaker, the Electronic Frontiers Foundation, the American Civil Liberties Union has become involved in recent years. It's been really exciting. Long-term AI challenges. The prominent issue that this community has been looking at is, well, what happens if what we've been talking about throughout this entire conference, what if we succeed at that? What if we are able to create true general artificial intelligence, intelligence that is able to successfully perform any of the intellectual tasks that we as humans can? And a range of questions within this. Does it just stop there, or can we rapidly improve beyond there to superintelligence? And what would the dynamics of that be? Would we have some sort of recursive self-improvement where the system improves on its own performance quickly and it rapidly reaches a level far beyond us? Or do we still need to put in hard time and progress to make incremental steps forward? And on this question, the long-term community is still, I think, divided. But one thing where I think there's general consensus is that even if we didn't have this rapid takeoff, intelligence is such a powerful thing, and general intelligence, well, our intelligence is what has allowed us to change this planet more than any species before us. And if we were to introduce an equivalent but different intelligence, the consequences would be massive in every walk of life. And if we were to do it, we should think carefully about what the consequences might be. So some of the strands of research that this community has been looking at include different types of forecasting, working with experts on expert elicitation, running surveys, doing scenario analysis, horizon scanning, measuring progress in different domains to try and figure out like how quickly we're progressing in different ways and what the bottlenecks might be, characterizing potential impacts and risks of artificial general intelligence, in particular, what might be the risky consequences be, and are there any potentials for catastrophic consequences? And many within the community think that without careful development of AI, there would be the potential for global catastrophic consequences. Following from that, how can we make sure that if that scenario does come out, how can we make sure that we can design AI so that these consequences don't come about? And a lot of this has involved developing technical research agendas for the safe development of artificial intelligence. And in recent years, what has been become known as the deployment problem. What if we manage to solve all of the technical safety questions associated with general artificial intelligence? We still have to put this into the world. How do we make sure that putting this incredibly powerful general purpose technology into the world results in the benefits of it being distributed across society and across the world rather than falling into the hands of one group over another? And how do we avoid this having destabilizing effects or resulting in conflict? Now, I think an important point to make here is that the people who are working on these long-term issues aren't necessarily doing it because they think we're 10 years away, or 8 years, or 15 years. As we've heard throughout the course of this conference, there's still a lot of work to be done. There are still so many things that we don't understand, and it's simply impossible to put a time frame on how long it will take us to solve some of the fundamental conceptual questions about intelligence. But the view of some of the people working on these longer-term issues is that given that we have this uncertainty, that we can't rule out that maybe everything goes well and we achieve this within 15 years, maybe it takes a lot longer. But given there's that possibility, and given that the consequences are so major, and given that the problems are going to require so much forethought and work and collaboration, at least some people within this broader community should be working on this issue now. So this is an issue that has received a bit of pushback. So for some people working on these very imminent, very urgent near-term issues, thinking about these long-term issues seems needlessly speculative and a distraction from some of the issues that are right in front of us, that are well-defined, that we really need to be making progress on right now. Another sort of pushback that has been raised is that if these systems are a long way in the future, well, it's very difficult to make progress on a hypothetical future technology that might not look very similar to what we're working with at the moment. How do you do concrete technical work on this technology that we don't have in front of us yet? And then in contrast, the view of some is that, well, look at all the funding that's going into AI research. Look at all the brilliant scientific talent that is being applied to this. Look at the rate of progress. We're driving full steam ahead at this incredible threshold, and we're not really thinking about what it will mean even when we get there. And it's not just enough to, once we get there, then try to figure out the solution to these problems. We need to be thinking about it well ahead of time. So, okay, this isn't just an excuse to show off all the pretty things I've seen around Prague in the last couple of days, although this is an amazing city. What I really want to try to highlight is that I think we'll miss a lot if we end up allowing these kind of communities, thinking about near-term AI and these longer-term prospects, if we allow these to sort of fragment and divide away from each other. I think there are more links than we necessarily realize between them, and more than that these communities can benefit from collaborating with each other. If we're working on the near-term issues, which are incredibly important and urgent, we also need to be asking ourselves, well, once we solve these, how can we be better prepared for the next big challenge, which will inevitably come along a little bit more quickly than we'd like? And if we're thinking about these longer-term issues, we need to ask ourselves, well, what are the things that we need to do now in order to shape the world so that the world, when we do develop AGI, is as well positioned for this momentous challenge as it possibly could be? And within that, I'm going to mainly target this at people thinking about the longer-term issues, because this is a conference about thinking towards human-level AI. And I'd like to make 4 key points. Well, one is there is technical research that we can do now that will help us make these more powerful future systems safe, most likely. And that will probably also have benefits for near-term systems that we're looking at. In the last couple of years, a whole range of papers and technical research agendas have been released looking at fundamental issues in the systems that we're working with at the moment, whether it's deep reinforcement learning systems or whatever it is, and figuring out what kind of safety challenges they might have that might also extrapolate to more powerful future systems. One nice example of this is a paper called Concrete Problems in AI Safety that was released a couple of years ago by researchers from Google Brain, OpenAI, Stanford, and others. And they looked at a range of issues, including reward hacking, how do you avoid a system finding ways to max out its reward function without actually achieving the goal that you want it to, and a number of other issues. All of this was done within the context of imagining a household cleaning robot with these particular characteristics. But as the authors themselves pointed out, if you look carefully at it, these issues are quite analogous to many of the issues that Nick Bostrom explores in his famous book, Superintelligence, which talks about existential risk from general AI. It's just that Nick is looking at a far more powerful system with a much greater range of actions available to it. And there have been a lot of other papers of this sort looking at interruptibility of systems, developing frameworks like DeepMind's grid worlds in which you can test out systems and see how they misbehave and make sure that they don't do that. But the underlying point is maybe not all of this will carry across, but there's a reasonable reason to think some of it will. If we pick out the right fundamental principles of these systems and we figure out how to make them safe, we'll be putting in place the building blocks we need for the safety of longer-term systems, even if we don't know exactly what those are going to look like. And at the same time, we'll be providing benefit for the near-term iterations of AI systems using these principles. A second point is this. We're now starting to shape in a big way the sort of legal and regulatory environment in which we develop and deploy AI. And the rules we put in place and the guidelines we put in place now will inevitably affect how we do research, what research we do, and how the systems develop and are deployed. To give just one of many examples, right now explainability of AI systems is becoming a very important topic. Now, this might lead to us prioritizing as a research community, making AI systems that are more fundamentally explainable, and perhaps prioritizing that over systems that are more capable and powerful, but less easy for us to understand. These rules might result in more funding going towards this, more research talent going towards these questions. And this then might have consequences for the kind of safety research we can do. It may be easier to do certain types of AI safety research with systems where we know exactly what's going on at different points and when systems are operating in ways that we don't expect. I don't have time to go into this in detail, but I highly recommend a talk by Victoria Kakovna of the Future of Life Institute and DeepMind at NIPS last year, where she goes exactly into this issue. And you could make similar points and explore similar issues about, the reliability of AI systems, accountability, how they use data, and so on. The precedents that we set now in terms of how we do research and what represents societally acceptable uses of AI will inevitably affect how AI is developed and used in the long term. We released a report earlier this year, The Malicious Use of AI, where we highlighted that the AI community really needs to now be thinking about what the ways are that fundamental research could be dual use, used both for positive but also for negative uses, and how can we make sure that the negative uses don't come about. And the ACM put out a call saying the same thing, saying that researchers should think about what the negative uses of their research should be when they're publishing papers, and that this should be reflected in the peer review process. This is commonplace in other sciences, in biological and chemical sciences, and will become more and more important as AI systems become more powerful and deployed in more systems. AI researchers do need to be thinking about how will this research be used and what will it lead to. This will only become more powerful, important as we go towards much more powerful systems. And there may even come a point, let's say if we're close to critical thresholds in the development of AGI, but we haven't solved some of the fundamental safety issues, where we might want to stop and think, how should we be publishing this research? In what way should we be, for example, thinking about withholding some of these things until we solve any associated safety issues? I mean, there are trade-offs here because openness in research is one of the most valuable and fundamentally important things in scientific research, and it's something that the AI community does so well already. But with research that has high consequence and the potential for major negative consequences, we should at least be thinking about these things. And the sooner we start thinking about these issues, what the range of consequences of our research will be, the more that this kind of way of thinking about things will develop. A completely different type of example is AI and warfare. So right now, AI could help develop much more effective targeted weapon systems. It could also revolutionize information gathering and processing on the battlefield. But in many ways, this is just sort of a taster of what's to come as we develop systems that are more general, more autonomous, able to do more long-term planning, control multiple units at the same time. And the fact that there's so much debate about it and that the research community is playing such a powerful role in this debate at the moment, it's a powerful tool. We have an opportunity now to think about how do we want AI research to be used? Is this a path that we go down? The further we go down this path, the harder it'll be to turn in other directions. So maybe there's an opportunity here. Now, I'm not saying AI should never be used in a military context, but I do think that we need to think carefully about where this might lead us. Lastly, the collaborations and cooperations and institutions that we put in place now will influence how well placed we are to handle the challenges that we have to come. So yesterday we had a fascinating session about the potential for a race in AI development and the potential risky consequences in the near and in the long term. Within the long-term research community, this is a concern because if we had multiple groups or multiple nations racing to be the first to develop general artificial intelligence, this might result in corner cutting on safety or deploying the technology before we really thought about the consequences fully. But now is a time when we can sort of put the conditions in place to make it less likely that we have this kind of race. The stakes on AI are already high, but they're only going to get higher as the technology becomes more powerful, more profitable, more useful in scientific research of different sorts. If we take, for example, collaboration between Europe, the US, and China, now is a time when we can figure out how we can work together, what our relative priorities are, what our cultural differences are, figure out frameworks where we can work together on the core issues while allowing some differentiation on issues where we simply have different priorities, whether it's on issues of privacy, on institutions, on what the priorities are and the urgency of deploying AI in different settings. We have this opportunity now. It may not be so easy 15 years from now, particularly if we go down a road where competition is emphasized over cooperation. Now, that's not to say that every issue that we're looking at are going to be continuous in this way. I'm going to run over this very quickly because I'm quite low on time. I think a useful thing to do is think about, well, what are the trends within the science and within the impacts on society that we can expect to be continuous in some ways, and what might represent sort of step changes or discontinuities. I think we can expect greater autonomy of systems, greater flexibility and generality, more efficient and effective uses of data, more data sources available as we put more sensors into the world and more actuators for AI to influence the world. We might expect small data to become more useful as we develop systems that are able to do more without such huge data sets. We can see computers getting more powerful and more compute being applied to training runs. We might see less of a dependence on these big data sets simply because AI systems are able to learn from doing simulations. And I think it's inevitable that we'll see AI being deployed in more and more real-world environments with more challenging real-world data sets. Now, you can follow from that and ask, what are going to be the impacts on the world? But that's a longer talk than I can give. And then we might expect to see completely discontinuous things, step changes, like breakthroughs that happen quickly in planning, problem solving, strategizing, other general cognition milestones of the sort we've been talking about for the last couple of days, where we just don't know what the answers are going to be. But when we have the answers, maybe we see a great leap forward in capability. Now, a lot of this talk has been focused on, well, if you care about the long term and the development of AGI, why should you care about all the things that are happening in the near term now? Well, it also works in the other direction. So a lot of the issues that we're looking at in the near term, such as those I listed in the beginning, these sort of represent a snapshot in time. They are the world as it exists right now. But the technology will evolve quite quickly, the world around it will evolve, and these issues will change and become more challenging quickly, and perhaps a little bit more quickly than we would ideally like. Now, it's my view that a lot of the tools and techniques that the more future-oriented community have been developing are really going to be very useful in helping us extend our near-term horizon a little on a lot of these concrete near-term issues. And that includes measurement of different sorts in AI progress, forecasting, horizon scanning, expertise elicitation, and even some first principles fundamental work. The point is that the long term, some things will remain long term, some things we'll just be wrong about, but some things will become short term more quickly than we'd like. So anything that allows us to be a little bit more prepared could be quite valuable. I'd like to finish by saying, well, just to sum up, we're at, I feel like, a historic point in that things are changing at such a fast rate. More funding than ever before is going into artificial intelligence. More of the brightest people in the world are starting to work on artificial intelligence. More of the brightest people not working on artificial intelligence, but with the expertise we need to answer some of the societal issues, are bringing their expertise to bear on these. Governments worldwide are developing plans and regulations and policies around AI. It feels like in the last couple of years, everybody's been bringing their attention to bear on artificial intelligence. The decisions we make now and the steps that we take now will inevitably affect the trajectory of AI in the coming years and decades to a really substantial extent. And to ignore this would be at our peril. There's a lot of benefit that I think, paying attention to near-term issues can bring the longer-term community, and that including the long-term issues can benefit the near-term community. I think we'd miss an awful lot if we didn't find a way of combining these communities, combining the best insights and methodologies from both these things to create a global community that has room for both the near and the long-term issues relating to beneficial artificial intelligence. I think that's an opportunity that we can't afford to miss. Thank you very much.
Thank you very much, Seán. It was a great, very comprehensive summary of the current developments and as well what we should be looking into. There are a number of questions coming. I would like to take just one now, because the other questions might be even more interesting to take in the panel, which we will have after the next speaker. So the question is from Jeff Thompson. Where is Jeff? Here. Jeff is asking, most AI safety research is on choosing a safe reward function. Why? Most general AI architectures are not based on reward functions.
Well, I'm probably not the best person to answer that question. I would normally defer to a more technical colleague. My understanding is that, right now, most AI systems aren't necessarily involving reward functions, but architectures that do involve things like reinforcement learning seem to be particularly valuable for systems that are able to exhibit generality, flexibility, and learning. You're shaking your head. I just know that, if you look at some of the work that DeepMind and OpenAI are doing as examples of groups who are working towards general AI, typically reward functions are involved quite a bit in it. And I think that's at least a justification for those groups and others to look at how to make sure that reward functions do what they're supposed to. I agree with you fully that this is only one little bit of the question, and I think one of the most important things for this community is not to get stuck in a local minimum where we're all focusing too narrowly on one aspect of AI safety associated with one particular technique. It is absolutely crucial that we consider what are all the other issues what are going to be the other ingredients that go into the pot that creates general intelligence, what are going to be the other safety issues that come into play when you introduce these things. So I agree with you in that this is one plausible approach that should have safety research done on it, but certainly not everything.
Thank you very much. And there are great questions from Zoe, Lukáš, and Mark, and we will take these during the panel after next speaker. So thank you very much.